New week, new chapter. We're going to shift gears from expressions to equations. One of our last sections in chapter 1 gave us a little taste of equations by talking about how they can be opened or closed and how they can present themselves as either true or false. And then we tested out some possible solutions. Well, on to the actual solving. I imagine the beginning of this chapter, these first 4 sections will go pretty quickly because we've all solved equations before. And then we'll get on to more in-depth work like the literal equations and so on. In order to discuss equations, we want to first talk about this equivalency. Can equations that appear to be different be equivalent? Give an example. We'll share those in class. On to our one-step equations. The goal here is to solve one-step equations in one variable. We'll use mental math, and we'll be using the properties of equality and one inverse operation. The properties of equality start off with addition and subtraction. Adding the same number to each side of an equation results in an equivalent equation, and subtracting the same number on each side of the equation will also result in an equivalent equation. Let's take a look at one of each. In this first one, I'm looking at x minus 3 equals 2. It's a subtraction equation, so I am going to add 3 to both sides. By adding 3 to both sides, a number plus its additive inverse will cancel out. And on the right, I just add. We can do a mental check on that. 5 minus 3, it equals 2. On the second side here, second example, I have an addition. So I'm going to use the subtraction property of equality by subtracting the same number on both sides of the equation. This will result in 3 minus 3 is 0, and 2 minus 3, negative 1. Negative 1 plus 3. Does that equal 2? Yes, it does. It checks. The one step, again, your goal is to isolate the variable. You also want to be sure that the coefficient of the variable is 1. In this problem, you notice that your variable is on the right side of the equal to sign. We're going to solve this the same way we did when it was on the left. We're going to inverse operation, use our property, or addition property of equality, and add 3 to both sides. When I simplify, I'm left with negative 4 is equal to x, and I just sort of reverse that because I'm solving for the variable, and I get x equals negative 4. To do the check, we just want to replace this value for x in our original equation. So 7 equals negative 4 minus 3. The rules of subtraction, if you remember, are to add the opposite. And when the signs are the same, you just add and keep the sign, and it works. 2 other properties of equality are the multiplication and the division properties. Multiplying each side or dividing each side by that same number produces an equivalent equation. 2 examples to test it out. 3x is equal to 6 3/10 is a multiplication equation. I'm going to use the division property of equality and divide both sides by 3. That's the inverse operation. I'm going to get x is equal to 2 1/10. If I were to take 2 1/10 and multiply that by 3, I would get 6 3/10. Next example said x divided by negative 3 equals negative 9. The inverse would be to multiply by the reciprocal here. If that's division, we'll multiply by negative 3 on both sides. It cancels on the right. Isolating my variable, x is equal to 27. And again, one-step equations, very straightforward. Time for you to try a few. In this first one, I see subtraction. My inverse operation is addition. When I'm adding, Anything plus its additive inverse cancels out, which is my goal. I get negative 6. Negative 6 minus 8 equals negative 14. Well, subtraction says to add the opposite. So I'm going to have a negative 6 minus negative 8 will give me negative 14. In the next one, I see that I have a fraction here. I'm going to write this one out horizontally. I'm going to look at the right side first because that's where my variable is, and that inverse of subtraction is addition. So I'm going to use my addition property of equality and add 3/2 to both sides. It will cancel on the right. And because the denominators are the same, I just keep the denominator and add the numerator. And I'll simplify to get y is equal to 2. Third problem, it's multiplication. So the division property of equality says if I divide both sides by 15, I can isolate my variable. If I simplify and divide by 5, I get an answer of 2/3. Last problem, let's multiply. Since I see division, the inverse would be to multiply both sides by 8. We're also getting a chance to review our rules of real numbers. A negative times a positive is a negative. And that's all there is to the one-step equations. Now, one last thing I do want to add to that is that sometimes your coefficient will be a fraction. And we can multiply by the reciprocal to eliminate that fraction. The reciprocal of 4/5 is 5/4. We'll use that multiplication property of equality and do the same on both sides. Anything times its reciprocal is 1. 1 times x is x. Let's simplify on the right by simplifying before we multiply by cross-canceling. And there's my solution. Let's see that again. Negative 2/3 x is equal to 12. Let's multiply by that reciprocal, which is a negative 3/2. Watching my signs, I'm going to simplify before I multiply by cross-canceling. 6 times a negative 3 gives me a negative 18. 2/3 x is equal to negative 3. Once again, to eliminate that fraction, let's multiply both sides by 3/2. Cancels on the left, isolating my variable. I get negative 9/2, which simplifies to a negative 4 1/2. Last problem. The reciprocal of a negative 1/4 would be negative 4. Let's multiply both sides by negative 4. X is now equal to a positive 32. One-step equations to solve one inverse operation using properties of equality. In our next session, we move on to those two steps. With a two-step, I can either be looking at two inverse operations, or I might need to combine like terms before I use an inverse operation. That's our goal for next lesson.